Hi, welcome back to es301 Engineering Analysis. This is chapter 2 of Programming and Software. So here are the learning goals of this video. At the end, you'll be able to interpret and create flowcharts for an algorithm. You'll know how pseudocode can and should be used to outline an algorithm development. And usually that's what you do at the beginning. You're going to outline it like the first step. And then finally, we'll just review a little MATLAB syntax. First, I want to discuss a little bit about flowcharts. And flowcharts are a way to sort of symbolically visualize a development of an algorithm in sort of kind of a real abstract sense or sort of a generalized sense. And historically, flowcharts used a series of symbols. And so here on the diagram, I show some of the primary flowchart symbols. Each symbol has a different shape to it so that when you draw it on the paper, you know what it is. And a couple of these are historic, and so, for example, this one right over here, which is called terminal, means that it would be getting some input from a terminal. What we'll look at is when we're drawing diagrams, we'll often have lines, and sometimes they will intersect, and we want to show that they don't mix there, but they actually are just crossing over each other. The most common step is just a process step. Something happens, and so that's done with this rectangle here. If you're querying input from the user, that's this angled quadrilateral that we have here. And another really common one is a decision tree, and that's right over here we're showing with a diamond. If two flowcharts or two flows are actually combining themselves, often you'll just give it a junction, which is a circle. And then, again, historically, these were done on paper, and so you might show that this is going to be continued on the next piece of paper. And then the last one, if you're doing a loop-controlled, a count-controlled loop, something is like a counter going 1 to the size of some array. So those are kind of the symbols. And so here's kind of what an example flowchart would look like from the textbook, where we have the flow coming in. So maybe there's a particular state of the program, and then it's going to evaluate some condition, and that condition could either be true or false, and depending on that, it's going to go into different directions. And so if it's false, then it's going to evaluate a second condition. If it's false, it's going to evaluate a third condition. And then if it's been false, all three of those, then it's going to go ahead and implement this process right over here, which is block 4. Regardless of which one of these blocks it goes through, we can go ahead and see that all the program is going to sort of come back together, and no matter which one of these paths it took, it's going to go down there. This is just kind of an example flowchart, and so this might be the algorithm for determining how to go ahead and maybe find the roots of some complicated equation. Well, let's just go ahead and if we were to develop one, let's just kind of start drawing one out. And so let's imagine for something just a little different. Let's imagine we're doing one for blackjack, for example. And so the very first step when you play blackjack is, well, you're going to go ahead and deal 2 cards. And so I might go ahead and just draw that as a process step, deal 2. And then the next thing that's going to happen is we're going to go ahead and query for input, right? We want to know whether the user wants to go ahead and hit or not. So that would be querying for input. And then we're going to go to the decision tree because either the user is going to want to get a hit or not. So maybe, for example, he does want more cards. So that would be my yes diagram, and there would be my no. And so if it's going to go ahead and we say yes, well, then we're going to go to a process step. And so the number of cards would be the number of cards plus 1. So now we've got an additional card. And then maybe you're going to go ahead and determine the total. And then it's going to come over to another decision, which would be, for example, is now that total greater than 21? Well, if it's greater than 21, so maybe this would be the yes step, then we would go down to a lose, and then the program would terminate. Now notice this over here with the very beginning where we said you want to hit no. Well, then you're going to want to go ahead and determine, well, is it greater than the dealer, right? So we need to go ahead and determine what the dealer's total is. Over here, if it's not greater than 21, well, then we're going to maybe want to go back over to go ahead and ask whether they want to be hit. And so I'm not going to finish this out, but you kind of get this idea where now we've got this kind of generalized idea. Now, each one of these steps right over here might be several lines of code. And so we haven't really written our program yet, but now we have a general idea where it's going to go. We're going to have if statements, for example, with each one of these decision trees. And then you go ahead and see we're going to have loop structures every time these arrows come back on each other. So when you're drawing a flowchart, you don't have to put in every single step, but you want to kind of combine several steps into some major grouping of what happens. I want to mention something about pseudocode. And pseudocode is something that happens between usually the flowchart and then your final computer code. So we just talked about what a flowchart is. It's kind of more generalized overview of how your algorithm works. And then the very final thing you want is actually the computer code that's going to implement the algorithm. And something in the middle is called pseudocode. So we're kind of going to one level of more detail without too much. And so to kind of show you an example of pseudocode, let's go back to this example we looked in chapter 1 where we had this force balance. And we were looking at the change in velocity and the time of our, this was of our skydiver, where we had our gravitational force, and then we had our frictional force, and at some point those would eventually become balanced. And so maybe we want to go ahead and do the Euler integration for this, and we looked at Euler integration, but we want to go ahead and write this down in pseudocode first before we sit down at the terminal and start writing our program. So here might be our pseudocode for that program. So remember the first thing we had our initial conditions. We might start off with assigning v and t to 0, and then implementing just these some declarations of what our time step is. I might call that v equals 2. And then what we're going to do is we're going to go ahead and loop through each one of those steps. So for example, maybe I want to determine how far the person falls in 10 seconds. So I'm going to do this while t is less than 10 seconds. And maybe I want to go ahead and first I need to calculate the drag coefficient. So maybe this is going to be the drag coefficient for those complicated geometries like I showed before. So maybe it's, like I said again, if this sort of here is that sphere, and maybe we had our one that was of our skydiver, which is fairly complicated. This is c, and this was a function of the velocity down here. And so we'd have to have some sort of determined, depending on what our value of v was, determined our value of c. So maybe that would be its own function, I'll just call that drag coefficient. This is where I'm kind of grouping several steps together. So I'm just saying, okay, this is the point where we go ahead and determine what our value of c is, and then we implement the equation for what dv dt is, and then we go ahead and step it through. Well, these are almost like exact lines of code, where this right over here is maybe several lines of code. And then we know, for example, maybe if the distance that he falls is greater than the height that he jumped from, well, then we're going to exit, because that means, I don't know, maybe you hit the ground, which might be bad. Or not, that we're just going to go ahead and continue. So this isn't exact code, this isn't MATLAB or C++, but it's kind of this general step, and now you can go ahead and implement it. Like that right there looks like almost an exact MATLAB code, whereas this one over here would have to look somewhat different. So that's kind of the idea of pseudocode, and it's a good intermediate step before you actually sit down and write the final program that you have. Yeah. So the last thing I want to do in this video is just kind of review some MATLAB, some of the important parts, because we're going to have some programming assignments in this class that will require you to use MATLAB. And since that's a prerequisite for this course, I'm going to make the assumption that you know it. One of the things we'll make use of a lot are arrays. So let me just remind you of a few things. In MATLAB, array indexing starts at 1. So if I wanted to know the very first element of an array called ARR, I would put it in number 1. There's no array element 0. Okay, so that is true in C++, but it's not true in MATLAB. If you want to know an index that may be dependent on another variable, like I plus 5, this would be where I is a variable. I can go and stick it inside there. MATLAB will interpret this and then stick in that number. If I want a range of values with the array, then we'll use the colon operator. I could go 1 to 5 if I knew the exact amount. There's this word end, which is just the end of the array. So it's whatever the length of it is, I can put that in. This will give me the entire array, all the elements in it. Another common thing we'll do is build arrays, kind of as we're stepping through. So imagine that skydiver problem where each point we're determining its new location. I could step through and save all those values. I could say the array I plus 1, which is the next one. And remember, we used the previous value, and then we had some increments. So I could go ahead and build this, and then MATLAB is going to continue to add elements to the end of my array. And you can also initialize it. Here I show an initialization where this is a two-dimensional matrix. 1 through 5 on the first row, and 2, 4, 6 on the second row. Remember, semicolon is sort of like hitting a return or a carriage return on the keyboard. So this gives me 1, 3, 5, go to the next line, 2, 4, 6. And so there's a two-dimensional matrix. Another thing to remember, if I have arrays and I want to do element-wise operations, so for example, if I had an array that was 1, 2, 3, all right, and then I wanted to go ahead and multiply that element-wise by maybe 2, 5, 2, and what I wanted to multiply was 1 by 2, and I wanted to multiply 2 by 5, etc., I do the dot in the multiplication. If I did that, then it would be 1 times 2 to get 2, 2 times 5 to give me 10, 3 times 2 to give me 6. Would be that. If I forget that, then I'm going to be doing matrix multiplication, which is often not what we normally want. It's called element-wise multiplication or division. Another thing we'll use a lot are functions. Remember, I just mentioned that you find the grad coefficient is in a function. What you do is you write your function as a separate M file, and then you call it with whatever the name of it is. So this would be my function, if it was my function.m, and then I give my parameters, common denominator, depending on how many they have. There's 0 to many parameters I have. I can set various variable types in it. If the function returns the value that I want, maybe I want to return it in the variable ret for return, I would say ret equals, and there would be my function. If it returns several values that I want to store, I'm going to put it into a matrix that I showed here. So I'm storing 2 values, return and error, that are coming from my function that takes 2 parameters, A and B. And last thing I just mentioned, the important branching. 2 important branches in MATLAB. We have if-else statements, or if-else if end. So that would be a decision tree. And then also I could have while loops. This is probably good to call that branching as much as loops. For example, while, and then I would have some sort of condition. So just kind of look at a couple examples here. We go ahead and erase some of that I put on there so you can see this a little bit better. Okay. So here I have a while loop, while in my condition, while I is less than 10. These parentheses are optional, but I think they're kind of helpful to group it, particularly if you have a complicated logical statement. Whatever's inside here has to evaluate to true or false. So you're going to determine whether the value of I is less than 10. And then here's my if statement. Again, the parentheses are optional, but it helps to encapsulate it. And this thing in here has to evaluate to true or false. So if value is greater than 10, it's going to do these steps. Else if, and so it's going to say value is less than 10, else it's going to do this third one. So those are my 3 options. This would be like on a flow chart, a decision tree where I had 1 option, 2 options, 3 options coming from that. One important thing to notice, there's no space in that else if. That's one word. If I had a space in there, it would be creating a whole other if statement. And so the syntax is a little bit different. There's the end statement that corresponds to the if. I'm doing some indentation to kind of help see this is one series of stuff going on in the while loop, and then this end statement goes with that while loop right there. All right, so let's just go ahead and review what we talked about in this video. Just kind of mentioned flowcharts. We saw their visual representations of how logic flows in an algorithm. They're a very good first step when developing an algorithm. The next step is pseudocode, kind of an intermediate step between flowcharts and your final computer code. It helps in incremental development because you can put several computer steps in there, and you don't have to get too bogged down in the syntax and kind of think how it's going to flow. And the last thing we just looked at here was just some review of MATLAB, the important parts, which would be arrays, functioning, and branching, and I should say branching and loops, which are kind of 2 separate things.